said to be for semi-continuous, CTS means continuous, semi-continuous. If F inverse minus infinity, alpha, alpha, for alpha belongs to set of real numbers. Capital R means set of real numbers. Right. Next. Page number 8. Just a minute. So for example, using this definition, we'll prove one theorem that is short answer type question. For example, G is a open set. G is a open set. G means example. If G is open set, If G is open set, if G is a open set in topological space X, in topological space, TP means topological, TPL, topological space, topological space X, topological space X. Then its characteristic function, then its characteristic function, characteristic, characteristic function, characteristic function, Xg is, Xg is, C is lower semi-continuous, lower semi-continuous, lower semi-continuous, lower semi-continuous, since for any, since for any lower, since for any alpha belongs to R, alpha belongs to R, alpha belongs to R. Xg inverse alpha infinity, Xg inverse infinity alpha, alpha infinity, alpha infinity, alpha infinity. That equal to, okay, signum function. This function is known as signum function. Pi, pi. If alpha greater than 1, alpha greater than 1. G, if alpha lies between 0 to 1, if alpha lies between 0 to 1 means 0 less than alpha less than 1, less than 1. X, if alpha less than or equal to 0, if alpha less than or equal to 0, alpha less than or equal to 0, and sets on the right are open in all cases, and the sets are open, open in all cases, in all cases, in all cases. Using this definition, one will prove one theorem that is for short answer type questions. Important. Theorem 1. Theorem 1. The supremum of any collection of, the supremum of show that or question formation is show that or prove that, like that. The supremum of any collection of the supremum of supremum of supremum of any collection of any collection of any collection of any collection of semi-continuous functions, semi-continuous functions, semi-continuous functions is lower semi-continuous, is lower semi-continuous, lower semi-continuous. CTS means continuous, lower semi-continuous. Continuous functions, continuous is lower semi-continuous, lower semi-continuous. Second bit. What is second bit? The infimum of any collection of the infimum of infimum infimum of any collection of any collection of any collection of any collection of collection of upper semi-continuous functions, upper semi-continuous continuous upper semi-continuous functions and its functions on a topological space X, on a topological space X, space topological space X, X topological infimum of semi-continuous functions, semi-continuous functions. A proof of theorem, proof, proof of theorem. First bit, first bit, proof. Suppose F alpha belongs to delta. Suppose F alpha belongs to delta. Alpha belongs to delta. Alpha belongs to delta. Is a collection of lower, is a collection of a collection a collection of is a collection of a collection of lower semi-continuous semi-continuous, lower semi-continuous, lower semi-continuous. Function on a topological space X. That function of topological space X, TPL, topological space topological space X, topological space X, topological space X, and F equal to F equal to and F equal to supremum F of A, supremum, SUP means supremum. A belongs to delta F of A, F of A, F of A. Then for any alpha belongs to R, then for any alpha belongs to R, alpha belongs to capital R, alpha belongs to R, alpha belongs to R. We have F inverse alpha, F inverse alpha comma infinity, alpha comma infinity. That equal to X belongs to small x belongs to capital X, X belongs to X, such that F of X belongs to alpha comma infinity. F of X belongs to alpha comma infinite, infinity, infinity. That equal to X belongs to X, X belongs to X, such that supremum of supremum of A belongs to delta, A belongs to delta, F of A, F of A, F of A, X, X greater than alpha. F of A greater than alpha. That equal to union A belongs to delta, union A belongs to delta, A belongs to delta. X belongs to capital X, X belongs to capital X, X belongs to capital X, such that F of A, F of A, yeah, X greater than alpha, greater than alpha. That equal to union of A belongs to A belongs to delta, F inverse A, F inverse A, alpha comma infinity, alpha comma infinity, alpha comma infinity. alpha comma infinity. And since the lower semi-continuity, since the lower semi-continuity, semi-continuity, continuity, semi-continuity, to f of alpha, f of a, to f of a, to f of a, f of a, of a, to f of a, to f of a. Use that, use that, use that, use that, use that. F of a inverse, f of a inverse, alpha infinity is open for each, is open for each, open for each. A belongs to delta. A belongs to delta. So that F inverse, so that F inverse, so that F inverse alpha comma infinity, alpha comma infinity is open, is open, is open when thus F is lower semi-continuous. F is lower semi-continuous. Lower semi. CTS means continuous. Lower semi-continuous. Lower semi-continuous. Lower semi-continuous. Lower semi-continuous. Lower semi-continuous. F is lower semi-continuous. So second part as usual. Second part is similar to one. Similar to one. Similar. Hence proved. This completes the proof. Hence proved. Hence proved. Next. Definition. 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 Next definition. Suppose f is a complex valued function. Suppose f is a complex valued function. Complex valued function. And a topological space X. And a topological space X. Topological space X. Topological space X. and MNF and NF, NF suffix here. That equal to X belongs to capital X. X belongs to capital X such that f of x is not equal to 0. F of x is not equal to 0. Is not equal. The support of f denoted by SF. The support of f. The support of f denoted by SF. Denoted by SF. SF means the supporter of f. Support of f. Support of the support of f denoted by SF is defined to be closure of NF. Is defined is defined is defined to be the closure of NF. To be the closure of to be the closure of NF. That is the support SF of F. That means the support SF support the support SF of F. F is given by SF is given by SF SF equal to NF NFF for any F X belongs to C. X belongs to C. X belongs to C. Suppose X is a topological space. Suppose X is a topology. TP means topology. TPL means topological space. Topological space. The collection of all complex valued continuous functions. The collection of the collection of the collection of all complex valued functions. All complex valued functions. Complex valued functions on X with compact support is with CPT means compact support is denoted by CCX is denoted by CCX. CCX means compact support of X. Thus, thus CCX equal to F F such that X to C F such that F X to C X to C X to C X to C X to C. C means complex. Is continuous and is CTS means continuous is continuous and FSF and SF is is compact compact. Theorem number two. Using this definition, we'll prove a theorem. Theorem number two. What is that? For any topological space X, for any theorem two, take it as one. So theorem number three. Oh, one more definition we'll discuss. Definition. Definition. Suppose X is a topological space. Suppose X is a topological space. Suppose X is a topological space. Space. X is a topological space. F X to 0, comma 1. X to 0, comma 1. 0, comma 1. Is a continuous function with a compact support. Is a continuous function with compact support. Support. Compact support. Compact support. So first one. If V is an open set in X, if V is an open set in X such that the such that such that such that the support SF support SF SF support SF of F of F is a subject of V is a subject of V V a subject of V. We write we write we write we write F belongs to V. F belongs to V. Second one. If K is a compact set in X, if K is a compact compact set in X, compact set in X, compact set in X, such that f of x equal to 1, such that f of x equal to 1. Such that f of x equal to 1. F of x equal to 1. For all x belongs to K. For all x belongs to K. We write K belongs to K proportional F. We write K proportional F. Proportional F. In the above notation, uh, K proportional F less than means K is a compact set. K proportional F proportional V means K is compact set. K is compact set. K is compact set. So theorem number 3. B. Urazan's lemma, most important. Urazan's lemma. Urazan lemma. One. So definition. So definition. 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 Suppose X is a topological compact R space. Suppose SP. Suppose X is a topological space. Topological R space. R space. Topological R space. A is a. So A is a positive linear functional. A is a positive real. A is a positive linear functional on linear functional FNL functional linear functional on CCX. CCX on CCX. And mu is the set of functions. Mu is the set of is the set of mu is the function set of function defined 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 in theorem point. A set E subset set set E is subset X is said to be P in A is said to be in A said to be in A said to be in the class MF class script MF script MF if mu of E if mu of E mu of E equal to mu of E supremum of mu of K such that A is subset U subset E K is compact K is compact. So theorem number 8. Theorem number theorem number 8. Ridge representation. Ridge representation. Ridge representation. Ridge representation theorem. Ridge representation. Suppose X is a locally compact R space. Suppose X is a State and proof, quotient formation is state and proof, Ries representation theorem, or sometimes they will give statement, you need to prove. You have to identify this is Ries. Suppose X is a locally compact Hausdorff space, CPT, compact Hausdorff space, Hausdorff space, local Hausdorff space, Hausdorff space, locally Hausdorff space. Space. And A is a positive linear functional, and A is a positive linear functional. Linear functional. Positive linear functional. On CCX. On CCX means compact. CCX means compact set. We discussed, you know, what is CCX? CCX, complex value. The support, compact support is denoted by CCX. Compact support is denoted by CCX. CCX. Then there is a sigma algebra. Then there is a sigma algebra. Sigma algebra. Sigma algebra. When there is a sigma algebra. M of subset of X. M of subset of X. Subset of X. M of subset of X. Subset of X. Subset of X. Which contain all Borel sets. Which contain all Borel sets. All Borel of set of X. Which contains all Borel sets of X. And a unique positive complete measure. Unique positive positive unique positive unique positive complete measure mu. Complete measure mu. Complete measure mu on M. On script M. Script M. Which represents and in the sense which represent which represent which represent which represent and symbol. In the sense that the sense that the sense that and f equal to integration x f d mu f d mu for all f belongs to CCX. CCX. So proof of theorem. Very lengthy. Make it short. If f equal to u plus iv, f equal to u plus iv, f equal to u plus iv. If f equal to u plus iv, where u and v are real functions in CCX, where u and v real functions, real functions u and v real functions, u and v real functions, real functions in CCX, CCX, CCX. Then the linearity of then the linearity of linearity LINEAR linearity of unsymbol linearity of unsymbol gives that front of f and symbol of f AU plus I and V and U plus and V I and V U plus IV like the complex number. So this can be written as integration x u d mu x u d mu plus I integration x v t mu, right? Provided the result is proved for real functions, then 1 of f is equal to integration x integration x f d mu for all real valued f in CCX valued f in CCX f in CCX CCX. So it follows that so on. And F equal to sigma I equal to 1 to n. Sigma I equal to 1 to n. F ui. F ui is less than or equal to sigma I equal to 1 to n. Yi plus epsilon. Yi plus epsilon. Epsilon delta ui is that equal to sigma equal to 1 to n. Up to 1 to n. Yi plus epsilon plus mod a mu of ei plus epsilon by n epsilon by n epsilon by n epsilon by n minus mod a mu of k that equal to sigma I equal to 1 to n equal to 1 to n yi minus epsilon mu of ei plus 2 epsilon sigma I equal to 1 to n equal to 1 to n mu of ei mu of ei plus epsilon by n epsilon by n epsilon by n n equal to 1 to n equal to 1 to n mod ai plus yi plus epsilon yi plus epsilon is less than or equal to less than or equal to integration x f d mu plus epsilon 2 mu of k plus mod a plus b plus epsilon. Since epsilon is arbitrary, we set and f is less than or equal to integration x f d mu f d mu. So here f such that by Eurasian's lemma is a function of f such that k less than f less than b, so that xk less than or equal to f less than or equal to. So mu of 1k 1 k, that equal to integration, that equal to integration xk d mu 1 xk d mu 1 d mu 1 less than or equal to x f d mu 1 f d mu 1 that equal to and f that equal to and f that equal to integration x f d mu 2 f d mu 2 less than or equal to integration xv d mu 2 that equal to mu 2v is less than mu 2 k plus epsilon. So this completes the proof, hence proved. Hence proved. Right. So today we discussed, we completed 10 lessons from major and minor. Okay. Hmm? Yeah. What we discussed, three theorems, and four definitions, three definitions. No. So the space you see of x positive linear function and it and definition and two theorems. Okay. So thank you very much. Wish you best of luck.